Okay, can people see this?
Yes.
Yes.
Okay, so yeah, as Yannick said, thank you for making it through to the final day, and we hope you've learned enough about the code to at least start using it and potentially start contributing to it. And we encourage that. We want contributions from the community. So the outline of this talk will be talking a little bit more about something you've heard mentioned throughout the week, the agile approach to project management, and a little more about how in practice to work with our GitHub repositories and the Git version control system. And then how you can contribute, both preparing to contribute. So the focus of this talk will be on external contributors to JEDI. So this would be people who might create your own fork or an institutional fork, and then do code modifications and then issue a pull request to our public repositories. Now, I know at least several people on participating in this academy will not work this way. If you are a close collaborator as part of our annual operation plan, AOP, then you'll have access to our internal repositories, and you can work out from our internal repositories and create your feature branches and bug fix branches there. But the instructions in this talk will be targeted more toward external contributions to our public repositories. So I'll talk about how to some things to keep in mind when you're contributing, making pull requests to our public repositories. Make sure that your branch is up to date with the develop branch. Make sure your code is adequately tested, as Mariam emphasized in her lecture yesterday and the activity. And make sure your code is adequately documented. And I'll talk about how you can document your code. And then I'll talk about the sort of the mechanics of how to go through a pull request and code reviews. And the activity today will be all of you doing pull requests and code reviews. So, no, it's not advancing. I had this problem the other day. Yeah, I'm gonna try to re-enter this. Yeah, now it's going. Yeah, I don't know why it freezes up like that sometimes. Okay, so the way of the JEDI project.
Mark, I'm sorry, we can't see your screen.
Oh, I need to share again, I guess. Yeah, that happened last time too. I don't know why I can't advance. My screen seems to freeze up. Okay, how's that?
I can see it. Thank you.
Okay, so the way of a JEDI, the JEDI project is collaborative. We want contributions from the community. We're a joint center where we have distributed partners and collaborators and stakeholders throughout the atmospheric science and forecasting community. And JEDI itself is a joint effort. We have a distributed team of software developers. Some of us are in Boulder, some of us are in Maryland, and others are distributed all over. So it's a challenge to be able to collaborate in this environment. And so we'll talk about the tools we use to do this. And you've heard the term Agile this week. Agile is, as Yannick said on Monday, this is the way that software development happens now. So most in the software engineering and software development community, most companies and most projects take an agile approach to software development. This means a lot of things to different people. There are specific approaches like Scrum or Kanban where that define a more specific set of rules on what agile means. But what they all have in common is that they encourage innovation. They encourage a flexibility. So JEDI, no project can be future-proof, but that's it's a useful concept. So we want JEDI to be flexible enough so that, you know, in 5 years, we don't know what new instruments there will be and we don't know what new models there may be, but we want JEDI to be flexible enough to adapt to that situation, whatever that may be. So we want to be responsive to our stakeholders, which includes our users and developers. So when users need some new feature or some new requirement, we want to be able to incorporate it in a fairly rapid time frame. And we want this to happen. The old approach to software development was sort of to get a list of requirements and then to go off and build the software, but that's not how the real world works. Sometimes the requirements change and we want to be able to respond to that. And then another core principle of agile software development is continuous delivery of functional software. It's better to finish something that's incomplete and deliver it to the community and then add to it as time goes on. So delivering something that works is sort of one of the core principles of agile development. Oh no, this happened again. No, I cannot advance. Maybe if I spend too much time on a slide.
Try to use your mouse to advance. It was at the problem the other day. It wasn't working.
Oh yeah, you're right. It worked.
The mouse was working.
Ah, thank you. Okay, so some of the principles, again, there are multiple.
It's not sharing again.
Okay.
Sorry.
No, thanks for telling me. So apologies for the technical difficulties, but I think that mouse trick will help. Okay, so now can you see this?
Yes.
That's okay. Okay, so as I said, that there's different approaches to agile, but they all have in common certain principles among them. So these are some of them. Among them are delivering working software frequently. Working software is the primary measure of success. Attention to technical excellence and self-organization of teams. And teams regularly reflect and adjust behavior in response to users and stakeholders. So there are a number of these principles, and how we achieve these goals in JEDI is through a number of tools. As you know, we use Git as a version control system and GitHub to distribute our repositories and our code, and also as a means for doing code reviews and pull requests, and for working together in a coordination of a distributed community of developers. So in addition to the pull requests and code reviews, we also make use of GitHub teams. So these are sort of discussion boards where you can post and communicate with different groups in an asynchronous way. So there may be somebody like several of our JEDI contributors are in Europe in a different time zone, so you can post something and people will see it at different times. And the Git Flow Paradigm, which I'll talk about, is a way to encourage both innovation and continuous delivery of functional software at the same time. We won't talk about, internally we use this project management tool called ZenHub, which is an extension to GitHub. And we won't talk about that today because it's only internally to JCSDA, but this is what we use for issue tracking, for project management, and it has some enhancements to code review, like tying issues to our annual operations plan. and putting in estimates for how difficult things are. Some tasks are more difficult than others. But if you don't have access to our internal repositories to raise issues, you can go to our forums. We have these public user support forums that, and they're just getting going. So there are not a lot of posts yet, but we hope that the traffic on these will increase. So you've seen JEDI on GitHub. So Git is the command line tool that you have been using throughout the week to create a branch and to pull the repositories from GitHub. GitHub is the web-based repository management. So GitHub is the website. Git you can run on your computer you can in principle run it without any remote repositories, but the way JEDI works, it's connected. The repositories on your local computer are connected to the remote repositories on GitHub. And so any changes to the base code on GitHub require these things called pull requests, which we will talk more about. And so Git Flow is a number of things. It's a philosophy for agile software development that emphasizes, as I said, both innovation and continuous delivery simultaneously. It's also a working principle. So if you don't follow the Git Flow conventions for naming your branches, then you will get scolded. We have a webhook that will, if you create a pull request to JCSDA, it will ask you to rename your branch so that it's consistent with the naming conventions that I'll talk about in a moment. It's also an actual application. So there is something that you can install, and you can look at the JEDI documentation for details. But this is an extension to Git. So and this is installed in the Singularity container, so you can play with it if you wish. So I wanted to exit this presentation and talk a bit about this Git Flow Paradigm. So I'll go back here. So this is from this website is a manifesto on the idea of Git Flow. It's very worth. It's a short article. It's very worthwhile to read. It was a blog post from 2010 where this software engineer proposed this approach. And so it's highly encouraged that you read that. And this diagram comes from that blog post. But the idea is that there are two permanent branches that exist all the time, develop and master. Master is exclusively for releases. So anytime any code is pushed to master, it's tagged with a release. So we've only had one of these public releases so far. But as you can see, going down here is time proceeding. So every push to master is associated with a tag. And then here in the develop branch, as time goes on, it has more development, but most of the work happens in what are called feature branches, which are temporary. So the idea is a feature branch would branch off of develop. You would make your modifications, and then it would merge back into develop. And it would only be merged back into develop if it passes all tests. And so the develop branch should always pass all tests. And this is where the development actually happens in the feature branches. And then as time goes on, you can branch off. So this column here is for release branches. So as time goes on, you can create a release branch, and you can add documentation and testing to it. And then eventually this release branch gets merged into master over here and gets a tag. So when the release branch is merged into master, it's also merged into develop. So those changes are merged into develop. There's also let's see. Okay, I don't see on the diagram, there's no bug fix branch. A bug fix branch is usually merged back into develop. A hot fix is some problem with the release branch. So if there's some problem with the release, then you can issue a hotfix branch and fix it, and then that is merged both into develop and master to fix the problem. So that's the idea of Git Flow. Again, it's highly recommended that you read this article down here. So some takeaways from that article. So master is for releases only. The develop is what the destination for pull requests. So if you're contributing code, you would want to contribute it to the develop branch. So that's not ready for, that should be public consumption, but it compiles and it passes all tests. So so the develop branch should be fairly mature code that will eventually get into the master branch at the next release. The feature branches, so all these in blue are temporary branches. So they would be created. The feature branches would normally branch off of develop and merge back into develop when they're done. And that's where most development happens. And that's where most external users will only really have to worry about feature branches and bug fix branches. The release branches are mainly for the JEDI team. And as it has been emphasized throughout the week, that feature branches should be short and focused. They should address a specific advancement or a feature or it's a specific code development, and it should be clear what they do. And the smaller they are, the more likely you're going to have somebody review it in a timely manner. A huge pull request that modifies 100 files can sit around for a while before it's hard for a reviewer to review it to figure out what's being done. So it's the branches should exist for days or weeks. You shouldn't have a feature branch sitting around for months. So how to prepare to contribute. So the idea, so this is the public repository of UFO on GitHub. JCSDA here is the organization. Let's see if I can't seem to have a cursor, but up there in the upper left, you see JCSDA is the organization. And then in the upper right, you see this thing called a fork. That's a GitHub concept as opposed to a Git concept. So this has to do with, and on Git, as you'll see, you can have multiple remote repositories. So the idea is you don't have, external users don't have write permission to this repository. So to make code changes, you will have to first fork the code, and you can fork that into your own GitHub account. It creates a copy of the code in your own GitHub account, or some institutions may choose to work from institutional forks. So you might have a fork for your a university or for your institution that multiple users can contribute to and create branches. So first fork the repositories you would like to work with. And then back on your command line, you would set up JCSDA as the develop branch, the JCSDA organization. So you would do a clone of after you fork it, then UFO will exist on your own account, and you can clone that. And then you can do this thing called an add upstream. You can add a multiple remote repositories. So you can add JCSDA as your upstream source. And then you can fetch the upstream code, and then you can check out. And if you do this git checkout -- track upstream develop, then the develop version on your computer will track the develop version at JCSDA. And this is what you want, as I said, in the Git Flow methodology. This is what you want to create your feature branches from, and then you can create feature branch from JCSDA develop with that command at the bottom, similar to the command you used this week to create your own feature branches of UFO. And then to implement code changes, once you have your feature branch locally, you can make your code changes. You can add them with the git add command and then commit them. And then the first time you push, you'll have to set the upstream. So the origin here would be your fork repository. So you do a git push and you set the upstream branch, and now this will create the feature branch on GitHub. Before this, it only existed on your local computer, but now it will exist on GitHub in your fork. And then you can continue to make changes as you make changes. You don't have to do that setup stream every time. You can just do a git push of your feature branch as you change them. And then periodically, as you're working, it's a good idea to continue to make sure your code doesn't diverge from develop. Make sure it's up to date with develop, so that when it is time to commit your code, do a pull request and contribute your code to JCSDA, it has to be up to date with develop. So multiple times, every day, at least once a day, you would want to check out the develop branch, pull the latest changes from upstream, which would be JCSDA, and then check out your feature branch and merge those changes into your feature branch, so that when you eventually do a pull request to JCSDA, it will only have your changes. And then adding tests and documentation, that's very important, as Mariam emphasized yesterday. If you contribute code that is not tested, then your code will not pass our continuous integration testing, because we have this thing called code coverage. And Mariam showed yesterday that it measures the amount of code that's executed in the tests in each repository, but it also checks the difference. So any new code that's contributed, if it's not tested, then it will fail this test, and you will be asked to add a test. So that's important to test any code that you contribute, and also adding documentation. We have two ways to add documentation. One is called Doxygen, which Ryan mentioned yesterday. This is documentation that is embedded in the source code itself. So in the C++ or Fortran code, these would be comments on particular subroutines and functions and classes. And with our second type of documentation, you've already seen. This is the documentation that appears on the JEDI docs, read the docs repository. And this has a lot of high-level documentation with context behind it. So here is an example of how you would add Doxygen documentation to Fortran source code. So it's comments that you would add, but they have a particular type of format. They start with this bang arrow sign, greater than sign, I guess. And then they have these directives. You see one of these directives here is the /brief, is a brief description of the function. /details is the further details. Doxygen accepts markdown format, so those two asterisks around my function would be a boldface, and the list there is a markdown list, so that would appear as a list. And then there are other directives like a date and a warning. If you know somewhere where this function that you've contributed does not apply, you would add limitations there. And note that this comment in the lower right, that Doxygen has problems with object-oriented Fortran features. So we're looking into possible alternatives. It has trouble, like for methods inside derived types, it has problems tracking those sometimes, and it has some problems with Fortran C bindings. But it's still good, yeah. And if you add these comments, you'll still see them in the Doxygen output. And so this is an example for C++ code. It's very similar. You have a comment block, but again, it has a special syntax. You start with a /* bang, and then it has the same types of directives here. Oh, and I should also see that in the Fortran case, you have, again, I don't think I have a cursor, but where it says subroutine my function and you see the integer intent and where you see the argument list, there's a bang less than sign where these add Doxygen comments for the argument inputs and outputs. So the arguments of the function can be documented that way. Whereas in C++, you can add these /param directives to define what the arguments are and whether they're intent in or intent out. And so these are some of there are many commands in Doxygen. So we've already talked about the brief and details. There's formula blocks you can add in. It understands LaTeX, and you can put in attentions or warnings or known bugs. So that's useful. So here's an example of a man page type of output. This isn't, it started from a real example, but I added this equation in here just to illustrate how to add an equation. But this is what it looks like in the HTML that's generated. This is the corresponding code. So again, you see this list here, 1, 2, 3, 4 is a markdown list. This test data interpolation is rendered as boldface here. And this, you can see how the date directives and the warnings are generated. This is the equation. It's that /f bracket is a displayed equation in LaTeX. So that's how to do that. And just an example of the output. So it has, in addition to putting out man pages like that in HTML, it also has a lot of useful diagrams. This is, for example, a class hierarchy. You can see that the test application that Mariam discussed yesterday has a bunch of subclasses here. And but the OOPS test class itself is a subclass of application along with these other ones. So it has these class hierarchy diagrams. It has include diagrams. This shows that the geometry.h file includes oops.mpi.h, and which includes vector and eigen. So it shows which files are included where, and it has call diagrams. You can see this function here calls these other routines. And it has caller graphs. So you can see this function on the left, the QG fields copy, is called by all of these functions. And you can follow that back. And you notice all of these end in a routine that has a _C at the end. So this is where Doxygen fails to track the C++ Fortran bindings, because those that have an _C are Fortran routines, but they're bound to C++ routines that have an _F90 end in that name. So if you want to follow this path further on where these things are called, you would have to look for the corresponding F90 routines and then follow it in C++. Doxygen and JEDI. So at the bottom of the page here, you can see the links to the JEDI docs page and the Academy page that we have for releases. We publish the Doxygen documentation and diagrams on the web. But if you're adding your own Doxygen comments, you can see how they look in HTML by first installing Doxygen and this GraphViz program, which package which generates the diagrams. So you can install that on your Mac with Homebrew or on Linux with apt or yum. So you can install Doxygen, and then you do each of the directories has an enable doc flag. So this is for oops, for example. And then you would build the bundle, and when you compile it, it would create HTML documentation in the subdirectory in the build directory. So here it would be in the directory oops docs HTML coming off your build directory. So then you could load that up into your local web browser, and see how your documentation is coming out. So this other, I also mentioned, we have the documentation website. So this is done, and this has higher level documentation, like for example, the theory behind bump, much of what Benjamin was presenting in the past few days. This is on our documentation. So it has higher level documentation like this, including the theoretical and mathematical background on some of these algorithms. And this, just like any other code at JCSDA, is a GitHub repository. So this is a repository called JEDI Docs, and that's on that's public as well. So you can, if you wanted to add high-level documentation for any code that you contribute, you can fork this repository just the way we showed for UFO. You can edit files and then create a pull request just like you do with the code. And this would also be subject to code reviews. So the actual files are written in something called restructured text, and they're converted to HTML by this thing called Sphinx. So Sphinx is a Python documentation generator. Read the Docs, it just publishes these. So there's a readthedocs.org that publishes our HTML documentation, but the real thing that generates the HTML is Sphinx. And in fact, the JEDI Academy web pages were done the same way, but they're not done through Read the Docs. They're just compiled with Sphinx and then hosted through Amazon. So just contributing code with respect to pull requests. So this is how you would do a pull request. So this shows a page where it's a personal fork. So this is a fork in my personal GitHub account of UFO. And so this is the, on GitHub, this shows what branch you're on. So this would be some feature branch. Again, the GitHub naming conventions, it has a feature slash my branch naming convention. So it starts with feature, saying it's a feature branch. And so you would go to this drop-down menu and go to your branch. And then you would, here's the button to issue a pull request. So you would do a pull request, and that would bring up a new window. So this is a window here. The most important thing here is this shows you here which branch is being merged into which. So the terminology pull request is a little confusing for people who haven't seen it, but the idea behind it is you're requesting that the JEDI project pull your changes into their code, so our code. So the idea is, so what's on, so you see that little arrow sign in the middle goes from right to left. So what's on the right is your branch, your feature branch. So the head repository would be your fork, and then it would be your feature branch. And then on the right, it's important to make sure the base repository is JCSDA, and the branch is developed. The default branch here might default to master because that's what's that's what you would download if you just cloned the repository. But be sure to switch that in that drop-down menu to develop, because as we said in the Git Flow sort of approach, all pull requests should go to develop. So make sure that goes to develop. Make sure that they are able to merge. If there are conflicts, if you made changes to files and those files changed also in JCSDA develop, there might be conflicts. So this has to do with this process I showed a few slides ago, where you would pull the latest changes from develop JCSDA and then merge them into your branch before you issue your pull request. So if there are any conflicts here, you would have to resolve them before you issue your pull request. Or sometimes you can do it after, but you have to you can issue the pull request and then resolve the conflicts. But it's best to do it before you create the pull request. And then so give it when you create the pull requests. This is that same page that came up during the pull request. Give it a good name and a good description that makes it clear what was done and why. And when you bring up this this pull request, there will be a template here that asks you a bunch of questions like what's the description of this? What bug does it fix? What feature does it add? What's the definition of done? So what the feature that you've just added, what does it do? And if if it addresses an issue like a GitHub issue number or a conversation on the JCSDA forums, then you would note that here. and put a reference to it. You would, so if you're, those contributors to our internal repositories can select their own reviewers, but external contributors would not be able to select their own reviewers. So after you issue the pull request, there will be a JEDI team member who would assign reviewers for this pull request to do the code reviews. And if you have in the description, if you're not able to assign reviewers, you can always in the description suggest reviewers who might know about the feature you're adding and have some insight and perspective on your contribution. And then when you're finally ready and this form is all filled out, then you can create your pull request. So those with access to our internal repositories, there are a few more steps. You can see there are labels and milestones that have to do with our own project management. And if you're doing this on an internal repository, there are also epics and estimates that you can assign. But for external contributors, you don't have to worry so much about that. We'll worry about it after the pull request goes in. So some guidelines for pull requests. Again, make them short and focused and explain what was done and why. Fill in the template. What does it mean for it to be done? Refer to the relevant conversations, identify appropriate reviewers, make sure your code is tested and documented, and be willing to change your code. Often after you've issued a pull request, some reviewers may ask you to change it. So you may have to make changes, confirm that it still passes the test, and then push it again to GitHub, and then code reviewers will be able to see it. And read the working principles and best developers sections of the JEDI documentation for more tips on a good pull request. And then the code reviews. So the purpose of these is to ensure that the overall health of the code improves over time. What does health mean? That means scope, functionality, clarity, efficiency, reliability. So your job is, if you are asked to do a code review, then you need to look at all these things and make sure it benefits the code in some way. And as far as your review, in order for your review to be useful, it has to be timely. It has to come. If you wait 2 weeks to do a code review, then the code is probably moved on, and it's probably too late. It may have already been merged because somebody else has done the review. So you need to do it quick for it to be useful. You need to be courteous. Try not to get into arguments. There's no. The goal is to improve the health of the code. There's no perfect code, only better code. So try to be constructive and try to come to a mutual solution that everybody agrees on, ideally. And again, as has been emphasized before, that there are additional benefits to these code reviews, that you're sharing knowledge among the team. So you may see something in a code review and learn a lot that you didn't know. You could do this with ECKit or C++, and so you can learn a lot, and you can leverage the skill sets of the different team members. And so some questions to ask yourself as a reviewer: does this improve the overall health of the code? I won't go through all of these, but you can make sure it's adequately tested and documented. Did somebody leave in print statements for debugging that shouldn't be there? Can the desired goal be achieved in a different way? Then that's a big one. Sometimes there might be a more efficient or a more generic way to solve the same problem. And again, make sure that you yourself have read the working principles and best practices for developers and the sections of the JEDI documentation. And this is where those are. So if you go to the JEDI documentation, right at the top level in the table of contents are the working principles. If you go into the inside JEDI section of the documentation, then there are best practices for developers here that talk more about Git Flow and how to issue a meaningful and informative pull request. And I'll stop there. Just a quick summary. So if your external contributors work from forks, follow these Git Flow principles when you're defining your branches. Most of your branches will be feature branches, so they'll start with feature / something. And make sure your code's tested and documented. And all code requests should happen, all code changes should happen through pull request to the develop branch on the JCSDA organization. That's important. And realize that you may be asked to do code reviews as well. So I will stop there.